Hello boys and girls, today we're going to be working with additive patterns, and what we're going to be doing today is we're going to be combining some of the lessons that we've been working in the past. We're going to be combining the coordinate plane, input-output tables, and using equations to create input-output tables. So, because we're going to be working with additive patterns today, we are going to be working with the equation that has addition in it. So that equation looks like this: y equals something, a number, plus x. And because it has an addition on there is why we know that this is going to be an additive pattern, because of the plus within the equation. Let me go ahead and give you an input-output table. What is the value of this column? The first one? X is right. This is going to be your y. 0, 1, 2, 3. The rule for this table is y equals 3 plus x. How would I find the value for y? What do I need to do? Well, the rule here tells us to add 3 plus 3 plus 3 plus 3 plus 3. Go ahead and pause the video so you can go ahead and fill in the remaining of this input-output table. If you have 3, 4, 5, and 6 as your values for your y, you are correct. Now that we have this information, we can go ahead and move from our table to ordered pairs. If you remember correctly from when we talked about the vocabulary of coordinate planes, ordered pairs consist of two numbers together in parentheses. The first number in my set of parentheses is known as my x coordinate, and the second number is known as your y coordinate. And to be able to have a set of ordered pairs, you need x values, which we're going to get from here, and y values, which we're going to get from here. So my first set of ordered pairs is going to be 0, 3. 0 as my first x value, 3 as my first y value. The second set is going to be 1, 4. 1 on my x, 4 on my y. 2, 5 is the next one. 2 on my x, 5 on my y. And the next one is going to be 3, 6. 3 on my x, 6 on my y. And we're going to be using these set of ordered pairs that we took from this table, which came from the equation, to create a coordinate plane that represents a pattern. Remember that a coordinate plane has an x-axis and it has a y-axis, which intersect at the origin. One, two, three, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And now all we're going to do is we're going to go right on up. 0 units to the right for my first dot. So that means that I start at the origin and I stay there because I'm not moving anything. I'm moving 0. And then 3 units up. 1, 2, 3. And I'm not picking up my pencil until I make that dot. 1 unit to the right, 4 units up. 1, 2, 3, 4. Now we're going to move 2 units to the right, 5 units up. 1, 2, 3, 4, 5. 3 units to the right. 6 units up. 1, 2, 3, 4, 5, 6. Could you predict where the next dot would go? If you say that it goes somewhere there, you're right. What about the next one after that? Would you say somewhere here? What about the next one after that? Maybe here? And then the next one maybe here? And here, and I can even go off the paper and know exactly where it's gonna go. I can make a very well-educated guess as to where the next one goes, because here you're looking at a pattern. There's a relationship between these numbers. They're going up in a certain way. To represent that pattern, we always use arrows. Like that. Those dots are going in a pattern, so we can kind of predict where the next one's going to go. And this pattern that we see here is called an additive pattern. Let's do another one so you can continue building on this skill. Let me give you the rule. Y equals 2 plus x. And now let me go ahead and give you a table. Remember, the first column is going to be your x, and the second column is going to be your y. Let me give you some values for your x. 0, 1, 2, 3, 4, 5, and 6. And now what I want you to do is I want you to pause the video, use your rule here to figure out the values for the y. Go ahead and pause the video. Go ahead and look at my numbers and see if they look like yours. You should have 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 2 plus 4 is 6, 2 plus 5 is 7, and 2 plus 6 is 8. And now, with this set of information and with this table that comes from this equation, we can go ahead and create our set of ordered pairs. Remember, this is going to be your x and that's going to be your y. So you're going to need 1 set, 2, 3, 4, 5, 6, 7 sets. Go ahead and pause the video again and create your set of ordered pairs. Okay, you should have a set of 0, 2, 1, 3, 2, 4, 3, 5, 4, 6, 5, 7, and 6, 8. And with these sets of ordered pairs, now you can move on to the third step in this type of problem, which is creating your coordinate plane. This is your x-axis. This is your y-axis. And this is your origin, which is 0, 0. And I'm going to put my values here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and let me go ahead and grab a pen, and I'm going to go right on up. First value, 0 units to the right. That means I stay at the origin, and 2 units up. 1, 2. And I'm not picking up my pencil until I make that dot. 1 unit to the right, 3 units up. 1, 2, 3. And I'm not picking up that pencil until I make that dot. 1, 2, 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5. 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And the last one, 6. 1, 2, 3, 4, 5, 6 units to the right, 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Could you predict where the next dot goes? If you say it goes around there, you're right. Could you predict where the next one would go? If you say it goes around there, you're also right. And then the next one would go here and here, and I can even go off the paper and kind of know where the next one goes because there's a pattern. When there's a pattern, you can kind of predict what's next. This pattern is represented with a nice straight arrow that represents where the next dots would go. And the type of pattern that we're looking at here is called additive. Additive patterns. Where do these patterns come from, boys and girls? How do we know that they're adding? How do we know that they're going to be moving up? Where do these numbers come from? What do they represent? To be able to understand that, boys and girls, we need to take a different approach to looking at these problems. Go ahead and turn the page. And then I want you to go ahead and write this. We're going to be writing a very short word problem to see a different way of looking at these types of problems. Here's the word problem. There's a little boy named Zach. And Zach has $4. His mom gives him $1 every day for school. How much money will he have every day for 5 days? Okay. These types of word problems that require more than one answer, because in reality what we want to know is how much he's having every single day for 5 days. So what we want is 5 different answers. These problems call for the use of an input-output table and to be able to see the relationship in the pattern. That way we continue predicting how much you would have the next day and the next day and the next day. So to do so, let's go ahead and create an input-output table. Okay. Again, this is my X column, and that's my Y column. And our word problem is talking about two things. It's talking about the money that Zach has and the days that he's receiving money. So one column represents the days and one column represents the money. And on day 1, well, actually, on day 0, before his mom even gives him anything on day 1, On day 0, he already had $4. Then, on Monday, his mom gives him $1. So that $1 plus the 4 that he already had makes a total of $5. Then on Tuesday, the second day, his mom gives him another $1. So that's $1 for Monday and $1 for Tuesday, plus the $4 he already had. So that's 4 plus 2 makes $6 that he has on Tuesday. Then on Wednesday, his mom gives him another $1, so that would be $3 because it's one for Monday, Tuesday, and Wednesday, $3. Plus the 4 he already had makes a total of $7. Then on the fourth day, which is Thursday, his mom gives him one more $1. So that would be $4, one for Monday, Tuesday, Wednesday, and Thursday, 4. Plus the 4 he already had. That makes $8. And lastly, on the 5th day, let me just extend my table. His mom gives him one more $1, so that's $5, one for Monday, Tuesday, Wednesday, Thursday, and Friday, $5. Plus the 4 he already had gives him a total of $9. We can clearly see just by the table that this is going to be an additive pattern because we're adding 4. Now let's look at the ordered pairs. Go ahead and pause the video now and fill in the ordered pairs for this problem. Okay, go ahead and check your work with mine. 0, 4, 1, 5, 2, 6, 3, 7, 4, 8, 5, 9. Now before we get into our coordinate graph, let's go ahead and look at these set of ordered pairs, boys and girls, because these set of ordered pairs, now that we have a problem, now that we have a value for the x and the y, these sets of ordered pairs mean something. Remember that a set of ordered pairs consists of an x and a y, and our column for the x represents the days, and the column for the y represents the money. So each ordered pair is telling you something. For example, the first one's telling you that on day 0, Zachary had 4 days. The next one is telling you that on day 1, he had 5. So on and so forth. We need to be able to take from these ordered pairs the information and express it in a sentence. And here's how the sentence is going to look. On day blank, which represents the x-axis, Zach had blank dollars, which represents the y-axis. Let's go ahead and make our first sentence with these ordered pairs. The first set of ordered pairs are 0, 4. And this is your x and that's your y. On day, and now we're going to look at the value of the x, which is 0. On day 0, Zach had, and now to find the amount of money that he had that day, we're going to look to the value of the y, which is 4. Zach had $4. Let's look at the next one, 1, 5. On day, and remember we're looking at the x to figure out the number of days it took. On day 1, Zach had, and now we need to look at the value of the y, which is 5, had $5. Let's do one more together. Let's do the next set of ordered pairs, 2, 6. This is your X and that's your Y. On day X, which is 2. On day 2, Zach had $6. Do you see how each set of ordered pairs tells you something? On day 0, he had $4. On day 1, he had 5. On day 2, he had 6. How much did he have on day 3? Go ahead and set the next set of ordered pairs. Pause the video and go ahead and write in the sentence for this set of ordered pairs. If you wrote that on day 3, Zach had $7, you really understand how to take these ordered pairs and create a sentence. And now that you know how to do that, we can go ahead and create our coordinate graph to really represent the pattern. And it should be an additive pattern because we already did addition here. And from here, we should be able to see that our graph also shows us an additive pattern. Remember, this is your x-axis, this is your y-axis, and right here where they intersect at 0, 0 is your origin. And remember, we're going to go right on up, right on up. Oh, I forgot to label my axes. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Okay, now we can go ahead and start hopping our way through. We're going to hop 0 units to the right. So I'm going to start at the origin. I'm going to stay there. And then 4 units up. 1, 2, 3, 4. 1 unit to the right. 5 units up. 2 units to the right. 6 units up. 3 units to the right. 7 units up. 4 units to the right. 8 units up. 5 units to the right. 9 units up. Could you predict where the next dot goes? Right around there? What about the next one? Right around there. And the next one, maybe here, 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 here. Keep on going forever. I can predict this pattern forever because there's a pattern. The pattern that we're looking at in this graph is called an additive pattern. How do I know? Because my table tells me to add. Okay, boys and girls, now let's backtrack a little bit. To be able to create this graph, first we need to have a set of ordered pairs. And these ordered pairs come from our input-output table. And the input-output table is based on a pattern. The pattern for this table specifically is going to be y equals the number 4 plus whatever the value of x is. So you take your equation, create a table, create a set of ordered pairs, graph your data, and show a relationship. Okay, boys and girls, I think you're ready to go ahead and get started on your independent practice.